Guys, welcome to our channel of Sciences and Mathematics. Today we're going to have a discussion on one of the topics, of course, in electrochemistry. And this is going to be the topic of electrolysis and electroplating. Of course, each of the sample questions that we try to handle, of course, it will be paramount for us to try and find out what kind of a concept are we trying to discuss, or maybe trying to gain a skill in this particular case. So in this case, the concept of electrolysis and electroplating are very essential in our day-to-day life. Now that we find them having a wider number of applications, which we are going to see maybe in a nutshell. So for that case, thank you. Welcome. So as I've said, the question that we are discussing on the board is from the concept of electrochemistry. That is from the topics, the subtopic of electrolysis. And of course, under this, we're going to discuss the concept of electroplating. Just in summary to appreciate, because one of the fundamental ways in which we're going to gain skills in this particular case is to try to appreciate this specific topic and its relevance in our day-to-day life. So in this case, we're going to see that the process of the concept of electroplating finds a wider range in our day-to-day lives, especially in the industry and maybe in manufacturing and even in commerce. So in this case, we try to look at the concept of jewelry and the ornaments. Most of them, of course, are decorated using this particular process of electroplating. Now that some of us maybe are conversant with, or maybe have a liking for maybe objects which may appear in different shades. So the concept of jewelry, or trying to make the jewelry presentable, uses the concept of electroplating. And then we find that in purification of metals, we find that the metals appear in form of compounds and ores in their natural state. So we use electrolysis in order to try and find out ways in which we can make them more pure for them to be applicable in our day-to-day use. So again, we find out that trying to change the textures of metals, like maybe to give an appearance of aluminium, etc., we can be able to do this process of electroplating in order to give maybe a different metal a specific texture. And we do electroplating to prevent corrosion, especially in items or equipment that are find their use in marine environment, where there's a lot of corrosion due to the salty water that is found there. And this one also is finds use in electronics, whereby electroplating facilitates conduction. This is conduction of electricity, so it may be all conducting current. So facilitate conduction in circuit boards. This is circuit boards for electronics. So that's one of the ways in which it can be used. And for electrolysis, this is essentially an extraction of metals. And then, of course, we have talked about from that for reduction of metals from their ores, or from their specific compounds. And then maybe it can be used also in the metal cleaning, like maybe trying to remove rust, etc. So in this case, of course, as we can see, there's a wider range apart from the ones that we have listed over the process of electrolysis and electroplating, which of course forms a fundamental basis for our question. But in that case, as we have said, it is good for us to try and appreciate the concept we are trying to learn and its specific applications in our day-to-day life. So basically, we just go to our question. And bearing in mind that in some of our videos that we have discussed the concept of electrochemistry, we're going to use those specific concepts. In any case, maybe we just have a mention of a few which will assist us to solve our problem. So the question states that a current of 3.50 amperes was passed to electroplate 129 grams of gold. Calculate the time in hours it will take. Note 1 ampere is equals 1 coulomb per second, and then the formula, and then the atomic weight for gold is 197 grams. So having been given that information, we're just going to list what we have been given. So there's a current of 3.50 amperes that was passed to electroplate. So the mass that was used, or mass deposited, is 129 grams of gold. Calculate the time it will take in hours. So we need to find T in hours. Calculate the time it will take in hours. So in that case, we are going to use the basic concept that we have learned about the current and charge, whereby we give charge, was this one, to Q, charge as current as the product of current times time. So in this case, these are going to use the standard units, that is amperes and seconds. So therefore, if we are required to find time in hours, we should bear in mind that we have that conversion to do. So in this case, the process of electroplating involves the reduction, of course, of gold from its ionic state to a deposit, which is a solid. So therefore, we are going to have an ionic equation for that kind of a reaction, whereby we are going to have gold deposited using this specific equation. Now from this, of course, we try to find out the mole ratio for this kind of a reaction. So this is 1 for iron, 1 electron produces 1 mole of gold. So the amount deposited, of course, we have been given as 129 grams of gold. So therefore, it implies that 1 mole of electron deposit 129 grams of gold. So therefore, our relationship for Q is equals IT is going to be given as. So we said that the charge that is going to be used is measured in Faradays. So therefore, 1 Faraday, which was 1 F, was equivalent to 485 coulombs. And for 1 electron, it's going to deposit 1 Faraday, which is equivalent to 96,485 coulombs. So therefore, the mole ratios is 1 to 1. So 1 electron to 1 mole of gold deposited. So therefore, we're going to have a relationship that the charge for 96,485 coulombs are going to deposit 1 mole, which is equivalent 197 grams, which you have been given here for the formula. I mean the atomic, that's atomic weight for that. We have been given 197 grams. But in actual sense, it was 129 grams of gold that were deposited in that electroplating process. So we have to find out the amount of charge that was used by doing a cross multiplication for 85,129 divided by 197. This is grams, coulombs. So therefore, our answer is going to be charge in coulombs. Which is going to be 63,180.5 coulombs. So you can just repeat the calculation to confirm that the answer that I'm giving on the board is correct. So 63,180 coulombs are the ones that were used to deposit 129 grams. So therefore, we'll find the time that was taken by just using this equation by equating 63,180.5 is equals 3.5 for current times the time in seconds. So therefore T is equals 63,180.5 divided by 3.5, which is going to give us basically 5 hours. So this is this will give us the answer in seconds, and then we have a division of 3600 per hour. So that's a second per hour. So we're going to do a multiplication for that to convert the time in hours, now that we have been requested to find the time in hours according to our question. So I hope that using this specific concept that we have mentioned, it will be easier for us to try and quantify the amount of mass that is deposited, or maybe the current that is used, using the Molar relationship from this equation that we have of course done here, and the amount of current to time and the charge relationship that I've listed on the board. So basically this from all these are constant, and we are going maybe to be, it will be mentioned somewhere in case we need to use it in our calculation. So one does not have to maybe memorize it all the time. So in that case, that is it for today. I hope that the process of electrolysis and electroplating is going to play a greater role, or maybe we're going to appreciate it as we come across it in our topic of electrochemistry and other related topics. So that is it for today, guys. Bye. God bless.